Hey everyone, it's Bradley Bush with another algebra video for you. Today we're talking about the rational zero theorem, our to-do list. First off, the definition of the rational zero theorem, and then we'll give you a couple worked examples. I'll also put the timestamps for these two items in the to-do list in the video description so you can skip ahead if you want. First off, the rational zero theorem. So this f right here is just a polynomial. It's just the generic version of a polynomial. So the first term here is your leading term, and the blue a sub n is your leading coefficient. N is the highest power that you see in the polynomial, and then it's in descending order. So the next one is one less, you see, and then you go down and you see the constant term at the end in green, a sub 0. So if f is a polynomial, then and it has integer coefficients, then all of the rational zeros of this polynomial can be represented by this block down here. So in other words, we take all of the factors of the constant term, and to make this clear, constant term is this one here, the very last one, and we divide that by all the factors of the leading coefficient. And the leading coefficient is the term right in front, the blue term right in front. And that gives us this list from which we know we can find all of the rational zeros. So again, these are not all the zeros of the polynomial. There still could be irrational or imaginary zeros. But from this list that we create, from all of these in the pink circle, the factors of the constant term over the factors of the leading coefficient, that creates this list. And from that list, we know that all the rational zeros exist. So not everyone in this list is a rational zero, but all the rational zeros exist in this list. So let's do an example to kind of solidify this. So here we have a function. Our function here is f, and it's negative x to the fourth plus 3x squared plus 4. All right. First, we should probably identify what the leading coefficient and the constant terms are. So the leading coefficient is right here. That's a sub n. And that is -1. And we have the constant term, which is positive 4. Now we just need factors. So what are factors of positive 4? Well, we have plus or minus 1. That plus or minus 1 kind of looks like a Chinese character. That's a little bit better. Plus or minus 1, plus or minus 2, and plus or minus 4. If you're wondering, excuse me, about those options, if you take plus 4 and plus 1, you get 4. If you take minus 1, minus 4, you get positive 4. And if you take negative 2 and negative 2, you get positive 4, and positive 2 and positive 2 give you negative 4. So all of those different combinations multiplied together gives us these 6 that we have here. And just as a note, plus or minus 2 is the same thing as plus 2 and minus 2. That's just a shorthand. All right, so what are factors of -1? Well, that's really easy. That's just plus or minus 1. Well, now we take the factors of the constant term and we put them over the factors. Let's copy them down here. And we put them over the factors of the leading coefficient, plus or minus 1. So after looking at this, we have to take these each one at a time now. So we have plus or minus 1 over plus or minus 1. Let's write that out. Plus or minus 1 divided by plus or minus 1. And what else do we have? Our next one is plus or minus 2 over plus or minus 2. I think I just said the wrong thing. Plus or minus 1. I meant to say plus or minus 2 over plus or minus 1. That's what I really meant. And the last one, so we take all the different combinations of the top of this fraction here all over the same plus or minus 1. So this one is then plus or minus 4 divided by plus or minus 1. And what we get from that, what do we get from that? That gives us just plus or minus 1, plus or minus 2, and plus or minus 4. So notice though something important. I want to reiterate. I mentioned this before, but I want to reiterate this. These solutions here, this basket, this list, we've got 6 of them. The positive 1, negative 1, positive 2, negative 2, positive 4, negative 4. Those are only options for rational roots. Remember, these other two, the irrational and the imaginary, those are not even being considered. So all of the rational roots that we have here are in this list of 6. We just don't know which ones are real and which ones aren't. But if we graph it, we can figure it out. So if we graphed it, we could easily see, so we graph the function f, we can easily see that 2 and negative 2, those are the actual only, those are the real, I shouldn't say real because then you think real versus imaginary, those are the valid roots in this list of 6. So notice up here there were 6 of them, and we're only taking those 2. The plus or minus 1 and plus or minus 4, those didn't end up being valid roots. So we can write that down here. Looks like x equals negative 2 and positive 2 are the only valid ones. So that was actually kind of cool, right? We got a list of 6 and 2 of them were valid ones, and we could just verify the valid ones just by looking at a graph. This is kind of an important note, because you might have been confused when I did plus or minus 4 divided by plus or minus 1, or plus or minus any constant divided by plus or minus any constant. So let me tell you how that actually works. Let's step through that now that you've seen it once. So what you do is you take each of the top signs and you pair it with each of the signs in the bottom. So for positive 4 with positive 1, that gives me this first one, positive 4, positive 1. And that gives me what? 4. The positive 4 and the negative 1 give me the second option, positive 4 and negative 1. And that, when you make the division, do the division, and gives you negative 4. Then next we will take the negative 1 in the top, and we pair it with the positive 1, and we pair it with the negative 1. So negative 4 with the positive 1 give us negative 4, and the negative 4 with the negative 1 give us positive 4. So we started out with this plus or minus 4 and divided by plus or minus 1. And when we went through all the options, the only unique numbers were 4, because you see we have a 4 here and a 4 here, and we had a negative 4 because we had a negative 4 here and negative 4 here. So there were repeats. After we did went through all of the options, there were some repeated values. So really the only options in the end, unique options, were positive or negative 4. And sometimes we just write that plus or minus 4. So that's how the math works on that. We'll be doing that a lot in this section. So after a little bit, you'll kind of get used to it. But at first, it's probably good to go through all the options like I did here, the 4 different options. So this compact writing, plus or minus 4 divided by plus or minus 1, gives you these 4 options, which turn out to just be 2 options in the end, 4 and -4. And we can write it compactly like that, plus or minus 4. All right, let's do another example and see how this one turns out. Well, let's start out with identifying the constant term, which is -6, and what is the leading coefficient? The leading coefficient is 4. So we write down 4. So what are factors of -6? Factors of -6, we have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. All factors of -6. Now let's look at factors of +4. That gives us plus or minus 1, plus or minus 2, and plus or minus 4. Awesome. Now we can put those, again, we can copy and paste. So that's what I'm going to do, right? There are values for all of the factors, I should say, for the constant term. And whoops, wasn't quite what I wanted. And all the factors of the leading coefficient. So notice now this example is a little more complex than the last one because the last one only had one item in the denominator. So it was easy just to take all the items in the top individually with that 1 in the bottom. But now we have to split that up. So we will take negative or plus or minus 1 by itself in the denominator. We'll take plus or minus 2 by itself in the denominator, and then we'll take plus or minus 4 by itself in the denominator. And notice all 3 of these have these same numbers in the numerator. So I'm just going to copy and paste them to save time. Now we just have to build a list. So let's start. We do the same thing we did in the last example. A little tedious, but you know, that's life, right? So plus or minus 1 over plus or minus 1, which gives us just plus or minus 1. Next option, whoops, start over. Those two, that gives us plus or minus 2. Next option, that gives us plus or minus 3. And next option, the last pair for this, that gives us plus or minus 6. All right, first one's done. Now let's move on to the plus or minus 2 in the denominator. First option is plus or minus 1/2. We don't have that yet, so let's add it. Awesome. What's the next option? The next option is plus or minus 2 over plus or minus 2, which gives us plus or minus 1. We already have that, so let's move on. Plus or minus, oh, this one's new. Plus or minus 3/2. We don't have that. And now let's look at the next one. Plus or minus 6 over plus or minus 2, that gives us plus or minus 3, which is already in the list. So let's just move on. Next is the plus or minus 4 in the denominator. Wow, look at that. That's a new one. Plus or minus 1/4. Let's see what the next one is. Plus or minus 2 over plus or minus 4. That's plus or minus 1/2. We already have that. Plus or minus 3 over plus or minus 4. That's new. Let's add that. Perfect. And the last one, plus or minus 6 over plus or minus 2, that can be simplified to plus or minus 3/2, which we already have. So there we go. This is our list. It's kind of big, huh? 1, 2, 3, 4, 5, 6, 7, 8. So 16. We have 16 options. Let me fix this. I shouldn't have plus or minus 3 over plus or minus 4. I should just have plus or minus 3/4. That's what I meant to write. So here's our list. Again, if we graph it, we can tell which of these are the actual valid ones. And if we look, well, look at, there's a 1 and a negative 3/4. So where are those? Let's find them. The 1, there's the positive 1, right? There's positive 1 and negative 3/4, negative 0.75. Where's that one? Negative 3/4. There you go. Negative 3/4. So it looks like the only two the only two valid options are x equals 1 and x equals negative 3/4. I'm going to rewrite that 1 because it's a pretty terrible one. There you go. Perfect. We can, just a note, we can combine what we're doing here with synthetic division and graphing to actually help us find all the zeros of polynomials. And that's the discussion that we have in a different video. So if you want to check that out, then you're welcome to check out the video entitled Finding All the Zeros of a Polynomial. Hopefully this was helpful. Hopefully it helped you a little bit. You understand hopefully a little bit better the rational zero theorem. If it was helpful, please like the video, subscribe to the channel, and thank you for watching.